Good morning. Welcome back to the stoichiometric equations intermediate first year lessons. Somebody proposed that the limiting reagent once again to be told, and we will explain with the problems also. Say first take the Bird's equation, chemical equation, then put into the chemical equation in the form of symbols and formula. Then balance the equation. Once the balance equation is there, if it is balanced totally and the given amounts are as per the balance equation, it is a stoichiometric equation, nothing is no limiting end. If anything is lesser compared to the balancing equation amounts, that is the limiting reagent. Simple example we will tell. The question is 0.5 moles of sulfuric acid is mixed with 0.2 moles of calcium hydroxide. It is an acid base. Of course not, it is a weak base, which is the limiting reagent. So 0.5 moles of, now I am writing directly the equation. Sulfuric acid H2SO4 plus calcium hydroxide gives calcium sulfate plus water, salt plus water. Now on the balancing, two hydrogens, it is nothing but 4 hydrogens, 2 H2O2, SO4, calcium, everything is balanced. That means 1 mole of sulfuric acid is reacting with 1 mole of calcium hydroxide gives 1 mole of calcium sulfate and 2 moles of water. There is a balance equation stoichiometry. If everything is given like this, no limiting agent or no excess agent. But what was given? 0.5 moles of sulfuric acid is given in the problem. 0.5 mole. Whereas calcium hydroxide is 0.2 mole. But what is required for 1 mole? 1 mole. 0.5, 0.5. Then you will get accordingly. So here the lesser amount is calcium hydroxide. So it is the limiting agent. If it would have been 0.5 mole. So limiting agent is calcium hydroxide. And now product, if somebody is asking the product how much is the calcium sulfate form, it is 0.2 mole. Very simple. Okay, this is the one. Now one more we will see. One more is simple. This thing, 50 kgs of nitrogen, 50 kgs of nitrogen is mixed with 10 kg of hydrogen and producing ammonia. So this is the word equation. Now I am converting into the actual, the symbolic or the formula equation. N2 plus H2 gives ammonia 2NH3. 2N, N2, H3. So 2 3s are 6. So nothing but 3H2. N2 plus 3H2 gives 2NH3. This is the balanced equation. Now, what was given? Here 1 mole of nitrogen, 3 moles of hydrogen gives 2 moles of ammonia. In kgs masses wise, N2 means 42 are 28. 28 grams or kgs, whatever it is. 3 2s are some 6.0, that is 2.01, 6.606 kgs gives the 3 plus 14, 17, 17 2s are 34. 34 kgs or grams ammonia is formed. Now that means for every 6 kgs of hydrogen, 28 kgs of nitrogen is required. Now what was given in the problem? 50 kg given in the problem is 50 kg of nitrogen and 10 kg of hydrogen. Here the ratio is around 4.5 roughly. So here the ratio is more. That means the limiting fellow is the hydrogen. It will remain slightly more. Okay. Now the whatever the product is coming according to this one. How much is product is coming? For 6.06 you are getting 34 kg. For 10 kg how much? 10 into 34 by 6.06 something. Then it comes to roughly lesser than the 5 6 of 34 from 5 6 6 5.6 means around 56 kgs. I'm not exactly calculating. So it is around 56. That is the, so limiting agent is hydrogen and the product is based on the limiting agent you are going to get. This is second example. Okay, now we will stop it here. We will further go, tomorrow we will see the normality and but we will start with the small explanation regarding the redox reactions, which is very most important in the chemical equations or chemical reactions or stoichiometry. So today we will start only the basic of the redox reactions. Basics of the redox reaction. It has started the oxidation and reduction together is called the redox. Reduction and oxidation. Many examples are rusting of iron and everybody knows and all these things. What was the first start? Initially it started, addition of oxygen is nothing but oxidation. That was the first starter. Please remember that this is not the final, this is only the starter. Oxidation was initially started as addition of oxygen. Why? Because of the following equations you see, please. Magnesium on reacting with oxygen gives magnesium oxide. 2 mg, you can balance the equation. 2 days. Okay. And similarly, sulfur plus oxygen gives sulfur dioxide. If you see these two reactions, here they proposed initially the chemist as addition of oxygen is oxidation and magnesium gets oxidized and compound is magnesium oxide, sulfur is sulfur oxide. Sulfur gets oxidized. But later on they have seen some more equations and they modified the definition of oxygen. Example is methane gas reacting with oxygen gives carbon dioxide and water. C and 2H2, 2H2O and 4 hydrogen, oxygen is 2 balanced. So this is the equation, and hydrogen sulfide on reacting with oxygen gives sulfur plus H2O. 2 to the 4 means 2 O's are 2 water. It is also balanced. 2S, 2 hydrogen. This is also balanced. Just see these equations. Here, not only the addition of oxygen, removal of hydrogen also is taking place. From here, hydrogen is removed. From here, hydrogen is removed. Oxygen is added. So, next oxidation definition is means modified as either removal of hydrogen or addition of oxygen. First one is addition of oxygen. The second one more sentence is added is addition of oxygen or removal of hydrogen gives the oxidation. This has solved some more problems, but further complication has arrived. That is third variety. This is the first, second definition, third. Again modification. No oxygen or no hydrogen involvement. Simple is magnesium plus chlorine gives magnesium chloride. Magnesium plus fluorine gives magnesium fluoride. Magnesium plus sulfur, magnesium sulfide. If you see, 3 equations. Magnesium I have taken as a common, chlorine, fluorine, sulfur. So all these cases, there is no oxygen, there is no hydrogen. So earlier 2 definitions, it is not fitting. So they further added that, what is this? This is a highly electronegative, this is also electronegative, this is also electronegative compared to magnesium. So addition of electronegative element is nothing but oxidation. Oxidation definition is further improved. Initially it was only addition of oxygen. Next is addition of oxygen or removal of hydrogen. Now addition of oxygen, removal of hydrogen or addition of electronegative element. Okay. So wide variety is covered. No, not yet stopped here. One more variety has come. So potassium ferrocyanide, FeCN6. Potassium ferrocyanide reacting with hydrogen peroxide gives potassium ferri. Ferri is CN6, but it is CN6. Yes, potassium ferri cyanide plus 2 KOH, 1 K has left, so K4, K3, so 2K3, 2K4, right, now it is balanced. Potassium ferrocyanide plus hydrogen peroxide gives potassium ferricyanide and KOH. Now here in this equation, if you see, now one more we can add. Not only the addition of electronegative element, here removal of electropositive also gives the oxidation. So there are 4 varieties. From this, finally it is concluded as oxidation means addition of oxygen or electronegative element to a substance, or removal of hydrogen or removal of electropositive element. That is the final this thing. Some more things tomorrow we will see. Good day.